Hey, welcome to a video where we are going to use the plane tool inside the 3D mode here of Onshape. And this plane tool is to create more we call them work planes, planes that we can use to do our work in space other than the location of our front, top, and right, or in different orientations. So as we model, we may need to make planes that are right in different places in space than these three. So it's a very important tool. We want to go ahead and look at this one before we start looking at some of the other tools in the 3D mode, just so we have a foundation of that. All right, so the intent of this video is that you guys would follow along. You can watch a little, pause, and then you try it on your own, and then resume the video and try again. We're going to try to touch every single type of plane here. There's 1, 2, 3, 4, 5, 6, 7, 8. There's 8 of them. So we're going to make a little more than 8 planes because some of them I'll do a couple. Okay. I find it helpful to have some other geometry to reference in here. So let's begin with a sketch. I'm going to use the top plane, and I'm going to make a rectangle. Let's make this rectangle 4 by 2. And I'm going to go ahead and make a circle over off to the side as well. And let's see, we're going to extrude both of these. And I'll just do a distance of 1 is fine. Okay, so we've got a couple things to reference along the way as we are using the plane tool. Think that as you are modeling a part, creating an object, that you will have started to bring some surfaces, some features into creation. And then those are surfaces that you can start to reference. So, right, we have possibly planes that we can reference, surfaces as if they're planes. We would have lines, we would have points, intersections where lines come together, and possibly even maybe curved surfaces. Okay, so we of course have the original 3 work planes, the front, top, right as well to reference. So the first tool, I'm looking for this tool. It kind of looks, it's just like a little square inside a big square at like an isometric angle. Okay, and so that's the plane symbol. And we're going to go to the very top of the list. And the first one is offset. So to create an offset plane, what that means is it creates a parallel plane to a selected plane or surface. So either use one of these 3 planes, or you can choose a surface of an object and you can create a parallel plane. So right here, and I'm going to rename these. So this is offset 1 and accept that. So that plane is just parallel to that right side of the box. Okay. Now, if you want to go nuts with that, you can. I could choose the top of the cylinder because that is a flat surface. That is a plane, right? So that would be something I could select. Offset 2. And I can also choose a plane itself instead of choosing a surface. So this offset plane, that's not really part of an object yet, it could be used in reference. And so it will just simply make a plane that is parallel to that. Now, in that offset, you can specify a very precise distance that you would have between those planes. So that is an important thing to note, that we can put that in there, that very exact distance. Okay, so that is the offset plane. Let's rename that one. I forgot to. So offset 3. So I've made 3. All right, now we may not want to keep all of these visible. So remember that we can show or hide all planes together with the P button on our keyboard. P as in plane, or one at a time. We can click the little eyeball to show or hide the visibility of each one. So if you think your document's getting kind of crazy and you would like to hide those, you can do that. All right, the next plane tool is the plane and point. All right, so, and actually for this one, let's go back into, I'm going to make sketch 1. No, that's not my top. Okay, let's make a sketch on the front plane right now, and I'm going to make just a diagonal line segment. Okay, that's it. So, gives us a little more geometry to work with. So with plane and point, you are going to specify a plane kind of like an offset, and that's going to determine the direction of the plane. Our plane will have to be parallel to the selected plane. So if I choose the top of this box, I will have to have a horizontal plane. The point comes in, it's plane and point, to specify basically that offset distance. I have to be parallel to this plane, but I have to go through a point that I select. So if I choose this point up here at the very top, that plane has to be horizontal like that one, parallel to it. Those are parallel planes, and it has to pass through that point. So that is plane, point. Parallel to plane through a point. Just like that. All right, the next one is called line angle. Okay, we're going to pick a line, and then we're going to pick an angle. By picking a line, Onshape has to generate a plane that contains the line. You need to think of that line now as a pivot point or a hinge. So there are a lot of different planes that can contain that line. Just like a door does not have to stay in one position as it touches the hinges, right, that it's hanging on. So that line acts like the hinge or the pivot, and so it can rotate around. Now, as you rotate that, you could just do that to eyeball, but you have the field here where you can specify an exact angle measure. And that is why it's called a line angle. Okay. All right. Again, remember to hit pause and to go create these on your own. You should be creating these as well. All right. Point normal. Now, let's maybe hide some of these planes that we've just created so we have less to look at. So a point normal plane specifies a point, just like it's in the name, and our plane is going to have to pass through that point. Now, there'd be an infinite number of planes that could go through that point. Just like, if I chose the line that point is on, it can kind of rotate in 360 degrees. There's really a bunch of different directions that plane could go. With only a single point, it could be just about anywhere. So we are also going to say that the plane has to be normal or perpendicular to a line. So we're picking a line and a point. And so I don't know if you can tell that as you orbit around, but this plane is perpendicular to that line, perpendicular in all directions. That's what normal means. And it passes through that point. If we had deselected that vertex and maybe chose, say, the midpoint, it would be perpendicular to that line and through the midpoint. If we got rid of that point and chose the other endpoint, right? So you get the idea. It has to go through the point we select, and it has to be perpendicular to the line that we select. So that is the point normal. Again, I'm renaming them so I can see over in my browser that I've created an example of each, at least one example. So that's point normal. All right, the next one down is 3 points. I'm going to go ahead and use my box as an example here. And again, I'll hide some of these other planes if that's easy. So I'm going to choose 3 non-collinear points. So the top plane does contain 4 points, kind of these 4 points, 1, 2, 3, 4, but it only takes 3 points to determine the direction of a plane in space. And so I want to choose 3 points that are not already part of a side of the box. So if I choose, how about 2 diagonal points on the top, and then say this point here, where the front, the right, and the bottom come together, this happens to be the origin. Oh, I got the line, not the point. It is going to create the plane that slices through those 3 points. So 3 non-collinear points will determine an exact plane in space. That is called 3 point. 3 point. And I will just add in parentheses that these are non-collinear, meaning they don't exist. These 3 points do not exist in a straight line. All right, the next one is a midplane. So a midplane basically bisects, kind of finds the exact middle in space of 2 planes that you have selected. You can, again, use planes, or you can choose surfaces. So if I chose, say, the 2 sides of my box, the right and left, I find a midplane right there. That's midplane of the box. If I chose, say, let's make another one, the top and bottom of my cylinder, that might be a handy thing to know, or exactly where middle is. So that'd be midplane, the cylinder. And those represent parallel planes. That's pretty easy to understand. But for the fun of it, if you use the midplane tool and choose two planes that are not parallel, it will still find in space the two or the plane that kind of splits the middle. It's the average of those two. So let's say I choose the bottom of this box and this diagonal plane, that was our 3-point plane. Okay. And so it finds kind of the average of those two. So that is a midplane. So the midplane can be used on any two planes. They do not have to be parallel. Midplane 3. All right. Let's see what's next in our list. Next up is curve and point. All right. So very much like the point normal one, I need a curve though. So I'm going to sketch. It really doesn't matter where. I'm just going to choose one of these planes. I just created some planes. Let's use one of them as my sketch surface. And I'll kind of hide. I'm pressing P to hide all those planes. So I'm sketching on, I think this was the midplane, is what I selected. Yep, midplane 3. And I'm going to use the spline tool. And I'm going to hold down shift so I don't get any kind of weird auto constraints. I'm just going to make a quick little S curve. I'm not going to go too crazy. Double click to end it and end my sketch. Okay. I just needed a curve instead of a line. So this tool, curve point, we specify a curve and then we specify a point. It's going to create I'm going to use any one of these control points along the spline. So what it's going to do is create a plane that is perpendicular to the curve at the exact point on the curve I've specified. Okay. Now curves aren't in a straight line. They're constantly changing direction. And so we can't really say we're like normal to the curve everywhere. It'd be just at one exact point. But this is very much like the point normal. It is just using a curve now instead of a line. So this is curve and point. So we get a plane that is perpendicular to the curve at that exact point and passes through that point as well. And we have one last one. And the last one in our list is tangent. So if you remember that when a line is tangent to a circle, it touches the circle at exactly one point. Well, here we're going to have a plane that is tangent to a surface or a curved surface, like the side of my cylinder, this curved surface. Okay, so I'm going to choose that curved surface. And Onshape here is kind of guessing for me. It doesn't really know, but it created a plane that just skims and touches the surface, and it doesn't touch it exactly one point. It touches actually in a line, in a bunch of points that would make a straight line. So now, because we're in three-dimensional space, right? Now, it just kind of guessed a vertical plane, and it guessed to put it on the left. I could say flip alignment, and it moves it to the right, but it's still using a horizontal plane. So it really doesn't know. I could choose, a different plane in a different direction. How about this? What if we had made a midplane between the front and the right, and we have this diagonal plane. Now maybe you're thinking, I want it to go this way. I can hit flip alignment. It'll bisect it going the other direction. And so we've got this diagonal plane. Maybe I want to be tangent to that surface and parallel to that diagonal one. So you can do that. You can choose, a plane that your new plane has to be parallel to. So I'm going to choose this new plane right there, that midplane we had created. And so here we have a plane parallel to that diagonal one and tangent to the surface. Now you can't pick any old plane. It does have to be a plane that could be compatible with that curved surface. It's possible to have a tangent plane and be parallel to that. There are some planes where that would not be possible. Like this one, I don't think is possible. So if I've chosen a curve and another plane, that's just not going to work. It's not compatible to be at that angle and tangent to that surface. It's not going to generate it. So let's get rid of the curve point plane and go back to choosing, how about that midplane, which currently is called plane 1. And so that is the tangent plane. And there you go. All right, those are all of the different plane tools that are available. And if you make them all visible at the same time, you got quite the mess of planes. But That's great for you to experience that tool and all that's inside of it.